So today we are going to discuss about the concept of random process. So random process is also called as stochastic process. So before going to random process, let us talk about random variable. We all know that in random variable, each and every element of sample space from random experiment is corresponded to the real number. So the sample space elements are corresponded to the real number. So as here in the example of tossing two coins, here the random variable is number of heads, then we have the elements of sample space is corresponded to the real number. So this is known as random variable. So now what is random process? So now random process. So if we read the definition of random process is a function of both sample space and time, and it is denoted as x of t comma s or x of t. See, in case of random variable, we did not have an encounter with time. So but in random process, the random process is a function of both sample space and time, or we can have another definition of random variable as random variable of random process. Random variable indexed with time is known as random process. So in random process, the involvement of time is very important, and we can also say that the sample space of the random process is continuous. So let us take an example for random process. So let us consider a group of students in a class, and let us take the random experiment of calculating their heights. So if we calculate their heights, then we are going to get not going to get the heights of 5 feet, 6 feet, exactly a particular value. We are going to get a different value for different kind of students. For example, we may get 5 feet 8 inches, 5 feet 9 inches, 5 feet 10 inches. We are going to get different values. So in random process, the sample space values are continuous. So let us consider this experiment. It is a very easy experiment. So now let us consider an experiment which measures the number of calls received in peak hours of a call center. So the number of calls received in peak hours is a random process, as the number of calls received at different time intervals may be different. So the number of calls of both sample space and time are, so here in this graph we can clearly see the number of sample space, number of calls received, and which time interval they have received. So at time t1 we received almost 10 calls, and time t2 we received almost 5 calls, and time t3 we received almost 13 calls, and at time t4 we received almost 15 calls. So this experiment says that the random process is dependent on time. It is indexed with time, the sample space elements, and it is a continuous in nature rather than in random variable. Random variable is discrete and random process is continuous, and it has infinite number of values between any two intervals. Thank you.